In this video, we will solve 34th question from second set of mechanical engineering question paper that was conducted in GATE 2018. The question is, air flows at the rate of 1.5 meter cube per second through a horizontal pipe with a gradually reducing cross-section as shown in the figure. The two cross-sections of the pipe have diameter 400 mm and 200 mm. Take the air density as 1.2 kg per meter cube and assume inviscid incompressible flow. The change in pressure P2 minus P1 in kilopascal between section 1 and 2 is option A minus 1.28, option B 2.56, option C minus 2.13, option D 1.28. You can refer to the NPTEL course, lecture number 6, Review of Fundamentals, Fluid Flow, Mechanical Engineering, coordinated by IIT Kharagpur. Before moving to the video solution, we need to know some basic concept. The first one is the conservation of mass. For an incompressible flow, the product of area and velocity at the section equal to area and velocity in the second section. This product is called the volume flow rate. A1V1 equal to A2V2 equal to Q. The second one is Bernoulli's equation. Bernoulli's equation is one of the most useful equations that is applied in a wide variety of fluid flow related problems. This equation can be derived in different ways. Example, by integrating Euler equation along a streamline, by applying first and second laws of thermodynamics to steady irrotational, inviscid and incompressible flow, etc. In a simple form, from the Bernoulli's equation relates the pressure, velocity and elevation between any 2 points in the flow field. It is a scalar equation and is given by P1 by rho g plus V1 square by 2g plus Z1 equal to P2 by rho g plus V2 square by 2g plus Z2. Or in other sense, we can write it as P by rho g plus V square by 2g plus Z equal to constant. This is nothing but the total head. Okay, now with these two equations, we can solve this question. Let us move to the video solution. Okay, now from the Bernoulli's equation, P1 by rho g plus V1 square by 2g plus Z1 equal to P2 by rho g plus V2 square by 2g plus Z2. Since both of the points 1 and 2 are at the same elevation, then Z1 equal to Z2, so this can be cancelled. P1 by rho g plus V1 square by 2g equal to P2 by rho g plus V2 square by 2g. But we don't know the velocities V1 and V2. But from conservation of mass, we know A1 V1 equal to A2 V2 equal to Q, or V1 equal to Q by A1, V2 equal to Q by A2. From the question, it is given Q equal to 1.5 meter cube per second. Okay, now what is A1? A1 is nothing but pi by 4 into the radius square. What is radius here? 400 mm at section 1. 400 mm is nothing but 0.4 meter whole square. That will give us 0.1256 meter square. And A2 is pi by 4 into a radius at this second section is 200 mm. That is nothing but 0.2 whole square. That will give us pi by 4 into 0.2 whole square. That is nothing but 0.0314 meter square. Okay, next we can, therefore from here we can find V1 and V2. Before that we will rearrange this equation. Okay, so we'll take, we wanted to find P2 minus P1 from the question, so we'll take P1 to this side, so that will give us P2 minus P1 by rho g equal to V2 to this side. That will give us V1 square minus V2 square by 2g. Okay. From here we can cancel g and g. Now we'll substitute V1 and V2. V1 is Q by A1. What is Q? 1.5 by 0.1256. So that will give us 1.5 divided by 0.1256 whole square minus 1.5. V2 is by A2. A2 is 0.0314 whole square divided by 2 equal to P2 minus P1 divided by rho. Okay, next, this is nothing but density of air is nothing but 1.2. So taking density to this side, we'll get P2 minus P1 equal to 1.2 divided by 2 into, okay, this is nothing but 142.63 minus 1.5 whole square divided by 1.5 divided by 0.0314 whole square is nothing but 2282.04. Multiplying 1.2 by 2 is 0.6. Therefore, this answer is nothing but minus 1283.64 Pascal. So that is nothing but minus 1283.64 Pascal. This is nothing but minus 1.28 kilo Pascal. Therefore, for this question, P2 minus P1 is nothing but minus 1.28 kilo Pascal. Moving to the slides, for this question, air flows at the rate of 1.5 meter cube per second through a horizontal pipe with a gradually reducing cross section as shown in the figure. The two cross section of the pipe have diameters 400 mm and 200 mm, and taking air density as 1.2 kg per meter cube and assuming invisible and incompressible flow, the change in pressure P2 minus P1 in kilopascal is minus 1.28. For more reference and clarification, you can refer to the NPTEL course, lecture number 6, Review of Fundamentals, Fluid Flow, Mechanical Engineering, coordinated by IIT Kharagpur. Thank you.